let's get real and talk about numbers, real numbers. So I'm going to tell you a little story about how numbers got invented. Once upon a time, there was a shepherd, and the shepherd had some sheep, and he needed a way to count his sheep, right? He needed to make sure that they were all there. So he invented a way of counting 1, 2, 3, 4, 5, and that system was called natural or counting numbers. Okay, and it started with 1, 2, 3, 4, 5, and on into infinity. Well, that was great. But one day, the shepherd couldn't find any of his sheep, and he didn't know how to communicate that. So to his natural or counting numbers, he added 0 to show that there were no sheep. And so we call those numbers whole numbers. And whole numbers are just counting numbers plus 0. Okay, so that way he was able to keep track of how many sheep he had, and he was able to communicate if he had no sheep. Well, unfortunately, this shepherd had a gambling problem. And he was in a poker game one day, and he had nothing to bet. He didn't have any money, but he had his sheep. And so he was on a losing streak. And he really wanted to make back his money, so he kind of took a loan. He bet double or nothing. And guess what? He lost again. And so not only did he have no sheep, he owed sheep. He had less than 0 sheep. And so he had to invent a system to show that. And that system is called integers. Now, integers are whole numbers, so 0, 1, 2, 3, 4, and the negative numbers, the opposite of natural or counting numbers. So he could describe any situation with his sheep. Well, almost. He turned lucky one day and he got back all his sheep, and he was so happy that he wanted to celebrate. And so he invited all his neighbors over. And what did he do? He cooked a sheep. We call that mutton, by the way. So he cooked his sheep, but guess what? He wasn't going to give every guest a whole sheep. He had to butcher the sheep, right? So he gave each person an equal part. And he needed some way to communicate that. And so to integers, he added fractions. Okay, what are fractions? Fractions ratio between two numbers, actually two integers. And so that is how rational numbers came to be. And rational numbers fill in all the gaps between integers, okay? So now you don't just go from 1 to 2. You can have a half. You can have a third. You can have a fifth. Anything that you can describe with a fraction where the denominator is not 0 is called a rational number. Okay, included in there are decimals as well. Decimals that end or decimals that repeat. And we'll talk about that a little later. Okay, so this is great. He can describe pieces of a sheep. He can describe no sheep. He can describe less than no sheep. That whole deal is great, rational numbers. But you know what? There's this other thing in the universe, maybe not in his universe, and there are other numbers called irrational numbers. And irrational numbers are numbers like pi or the square root of 2. Well, the shepherd can't cut his sheep into pi or square root of 2. Okay, so those are called irrational. Anything that does not fit into whole numbers, negative numbers, fractions are called irrational numbers. The collection of all of those numbers, rational and irrational, is called real numbers. Okay, and life is not so simple, so outside of this universe of real numbers, there's actually this thing called imaginary numbers. Sounds kind of intriguing, right? Well, imaginary numbers, you have to go a little further in math to learn about imaginary numbers. Okay? But this is the real numbers inside this kind of universe. I want to explain to you just briefly another way of dealing with rational versus irrational, because that's an important difference. Okay? In the real world outside of math, rational means not crazy, something that makes sense, something that's logical. And when we think of numbers, okay, we can think, rational, well, it has the word ratio in it. That deals with the fraction aspect. But rational numbers are things we can understand. They're not too crazy, right? Well, what fits into that? Whole numbers, right? Fractions. Anything that's written as a fraction. And also decimals. Okay? Decimals that end, which is called terminating decimals, right? So 0.5, for example. Okay, we know that's a half. That makes sense. It's rational. It's not crazy. All right, and what about this? 0.3 repeating. Well, that's a third. We can understand that. So that's a rational number. What are examples of, well, let's do one more. If I tell you the square root of 16 is rational, that makes sense too, because the square root of what we call a perfect square, I can express that as 4, because 4 times 4 is 16. What about irrational numbers? Irrational numbers, they don't make any sense right away to us, okay? Because we can't express them as a fraction. We can't express them as a decimal that repeats or that ends, okay? So something like pi, because pi, when we represent it as a decimal, does not end, does not repeat. The square root of 2 is a common one. The square root of 2 is irrational because it is the square root of a number that's not a perfect square. So if we try to express that as a decimal, it would also never end, never repeat, drive us crazy, which is irrational, okay? So rational is all the numbers that we're used to, that we can understand, that we can express. Fractions, whole numbers, negative integers, square root of perfect squares, decimals, that we can make sense of. Irrational numbers, well, on the crazy side, pi, which we can't really picture as a decimal, square root of 2, square root of 15, square root of any number that's not a perfect square. So, real numbers consist of rational and irrational numbers.